Starting. All attendees are in listen-only mode.
Hello, good morning. My name is Adrian Jensen. I work for Predictive Engineering, and we've also got Nate Anderson on the line. Morning.
Good morning, guys.
And today we're going to be doing it's a fairly short webinar, should maybe be about half an hour or so, and we're going to work on surface modeling. And in this webinar, we've got some solid geometry here. We're going to work through the geometry preparation of creating a sheet solid. We're going to do some little modifications to help produce higher quality mesh, and then we're going to mesh the structure. And that's where we're going to end. We're not going to do any analysis for this one. It's purely based on the meshing process. We've also got an API at the end that I want to present that was recently written. And that's about it. So we'll get started here. If you guys have any questions, there's a question section on the GoToWebinar little software, and you can ask a question, and maybe while I'm working through it, Nate can address your questions, or we can address them at the end. And as always, if you have our email addresses, you can send your questions directly to us, and we can address them later on. But let's get started. So I've got this model here. It's a model file, and this starting model file will be available on the web with a recording of the webinar if you guys want to try and work through this later on. And since we're in Portland, Oregon here, which is just the Northwest Brewers capital, I figured I'd make a fermentation tank today. It's a good little pressure vessel example, but it's a little more interesting than your average evaporator because it makes beer. So if we look at this, this is a solid body, and I'm going to kind of look at everything through the tree here. So it's got thickness, and what we want to create is a sheet solid rather than a body solid. So a sheet solid is going to be made of multiple surfaces, but it's not going to have any volume. One sec. All right, there we go. So I'm going to start by blanking some of the solids here. You can see that each component is its own individual solid in the model tree. And I'm going to blank the main tank here, and we're going to do mid-surfacing on the supports first. And the very common tool to create these mid-surfaces automatically is Geometry Mid-Surface Automatic. And it tells me select surfaces to mid-surface. So basically what I want is kind of an inside face and an outside face, and it'll create a mid-surface between the two. What we can do here is just grab all of these surfaces, and it'll sort out what we need. We'll just make sure we have all of these. Now, sometimes you can go through and pick these individually. I held down the Shift key and click and drag. That gives me this little selection box. You can also hold down the Control key and click and drag for the little circular pick. So there's lots of different ways to pick, and for the newer users, I'll try and work through different techniques so you guys can see those throughout the process. Alright, so now I need to pick my target thickness. And I'm going to zoom in here on the model, and I'm just going to measure directly off of this pipe here for my thickness. And they give you a little measure button. And I'm going to measure from that point on the inside surface to that point there on the outside surface. Okay, so 0.3. We click OK, and in the message box here, you can see it gives us some information on the process. And also, if you look in the model info tree, we've got all this new stuff sitting under geometry, all these mid-surfaces. So let's go ahead. I'm going to highlight just the mid-surfaces that got created by this command. I'm going to right-click out here and say Show Selected Only. So these are the only entities I'm seeing. My original geometry is still here, but I've just got it blanked. So these are our surfaces, and you can see they have no thickness. And I want to join them all together so I kind of have one continuous structure here. There's a couple of different commands that we can do. First of all, there's Stitch. And there's also one called Non-Manifold Add. And we're going to work through both techniques here and describe the difference of them, when you would use one, when you would use the other. And sometimes you need to use the combination of both. So we're going to start Geometry, Solid, stitch. And if you look at the top of the selection, select surfaces to stitch. So we want to stitch all of these surfaces together. There's that shift, click and drag, and the highlight. Okay. And now we've got a gap tolerance. So if these surfaces weren't perfectly adjacent to one another, we could choose what sort of gap tolerance we would be able to fill in with this command. We're just going to leave it with the default, and we click OK. At this point, Stitch gives us a plot of our free edges, and it's got them labeled with the IDs of the curves. And if we zoom in here, we can see that at the edge of this pipe, this circular curve here, that's a free edge. It's not connected to anything else. But the seam line running down the edge is not highlighted. It is not a free edge. So these two halves of this cylinder are continuous. And let's cruise down at the bottom here. You can see the same with the bottom and these kind of internal pipes here. But if we look in the model info tree, we don't have one body here. We actually still have multiple bodies. So let's kind of blank these, and you can see that we've joined together the separate halves of these cylinders, but we haven't joined together all the cylinders. And that's because of these complicated intersections down here. This is called a non-manifold intersection. And the way we always describe it is kind of like letters of an alphabet. An L is manifold. It's just a simple 90-degree connection. And I'll draw this out on the screen here. So there's an L, and this is our connection. But something that's non-manifold would be something like a T, where this intersection here, you're connecting more than two surfaces. There are more than two surfaces are sharing a curve. And you can imagine that these intersecting cylinders down here are even more complicated. So I'm going to do undo, and I'm going to undo before the stitch. And you can see in the model info tree I'm back to just my mid surfaces. And we're going to use geometry surface non-manifold add. And we're going to pick solids. Select solids to add. So basically 12 through 27. We're going to just pick those off the screen. Okay. Alright, so we get the same free edge plot. And you can see that the free edges are the same at the top and the bottom of the cylinders in these little internal sections here. But if you look in the model info tree, we now only have one general body add, or one non-manifold solid. So this is one piece here. If you blank that, you see it goes away. This is going to be a little bit easier to manage, and it's also going to help us out with meshing later on, because we don't have to worry about these intersections between components matching up. It's one continuous solid, and our mesh will be continuous. I'm going to leave this where it is for now and switch over to the main tank, and then we'll come back later on and join them all together. So let's do the tank. Oh, I've also got these little pipe supports here. I'm going to do these real quick. Mid-surface, automatic. I'll grab these here, and we'll measure. These ones are pretty straightforward. From there to there. And there we go. You can see we have a few more mid-surfaces to work with. So we'll blank those. We don't need those right now. We just want the main fermentation tank. Same process again. Mid-surface, automatic. And I've been talking about my picking techniques. I can pick these. I can use the boxes and the circles. Another command that I like is under methods here, and we can say on solid. So I only have to pick this one solid, and it'll pick all of the surfaces on that solid. Can make things a little bit easier there. We need to pick a target thickness, and I'm just going to zoom into the bottom here and measure the thickness right here. There you go, 1 inch. It's a little more complicated structure. It's taken some time to crank through and create all the mid-surfaces. And there we go. In the model tree, you can see that we've populated with more new mid-surfaces. So I'm going to blank the original solid body, And we just have all the surfaces to work with now. And again, we're going to work through some of our same commands. First, we'll try stitch, geometry, solid, stitch. I'm going to select all of these surfaces. Okay, we'll use our default. We hit OK. And now it's time to look at our free edge plot. So we've got a free edge between the knuckle and the main shell of our fermentation tank. And if we zoom in here, we can zoom in, we might have to zoom in quite a bit. We can start to see that there's actually a little bit of overlap in those two surfaces here. So maybe there was an issue with our original geometry or when we did the mid-surfacing, but we've got an overlap. So that's not, they're not perfectly adjacent and they're not merging. If we zoom back out and take a look at our little access port here, we're having similar issues. Again, we have to zoom way in. And the more we zoom in, the closer we get, we see we actually have a gap between these surfaces. Fortunately, stitch has a gap tolerance, so maybe with a bigger gap tolerance, we'll be able to stitch these together. I'm going to undo, Control-Z. You can see down here, undoing solid stitch. And we'll try it again. Solid, stitch. We'll grab these. We're going to go for a bigger gap tolerance. There we go. So we've joined the knuckle and the shell region up here with no problem. And we've joined these lines here between the different sections of this access port. But you can see that there's still a few free edges in here that we haven't taken care of. And if we look at the model info tree, we've still got actually two separate stitch bodies. There's the main tank here and this rim of this access port. And if we zoom in a little bit more, you can actually see that there's a little lip on the inside there. So that's going to create a T-style or non-manifold intersection. So we're going to need non-manifold add, geometry, surface, non-manifold add. We're going to need this command to join these two parts together because of that complicated intersection. We click OK. You can see in the model tree it's all just one general body add now. And our only free edges are at the openings and at the edge of this little lip here. We can actually delete that. We can remove that before we move on. Okay, so we've got our separate components here. We just need to do a little bit of prep work, and then we can add them all together into one large body. But before we do that, I want to investigate a little bit. Why did we have these problems here? And how do we know if we've gotten a good connection between our non-manifold parts? I'm going to introduce real quick the meshing toolbox. And what we want to look at is the entity locator. So we're going to toggle the entity locator. And you can see we have a lot of different options of what we can display. Let's take a look at our free edges. And you can see it brings back that plot that we got after the stitch command or after the non-manifold add. We can look around the model and we can see the free edges of all of our parts. And so it's always good to see that we don't have free edges in these sections that should be continuous. But at the tops and the bottoms of the pipes, at the openings, we have free edges. Let's look at non-manifold edges. And there we go. That junction between these two pieces that required non-manifold add, that's highlighted. And then our junctions, this is a little hard to see, yellow on white, but these are the junctions of the lower structure that required non-manifold add. Another good one to check is short edges. And right now, if we go to curve length, you could choose a specific length and say anything under this size, which is 0.28 inches, highlight curves shorter than 0.28. So if we show these, we've got some tiny ones in here. And these are actually located on the original fermentation tank geometry. And again, a lot of these small features you really have to zoom in a lot to see, and that's why the entity locator is so useful. So you can see we actually have this small sliver here, a small step, and maybe the flaws in this original CAD geometry is what led to the gaps in our surfaces later on. So we're going to use this tool a little more later on. I just wanted to introduce it. I can turn this off. We'll toggle. There we go. And we'll go back to our mid-surfacing. All right, like I said, there's a little bit of preparation here. I need to delete off some surfaces. These guys have some leftover components here, some of the piping that pokes through here. So I'm going to delete those surfaces. Delete geometry surface. And I'm going to use my little control click drag to get this circular selection. And that makes it easy to reach in there and get rid of all those surfaces. There we go. So we clean out the extra there. Let's work our way down. We've got our pipe supports and our main vessel here. All we had to clean up here was this small lip. We're going to delete geometry surface. Sometimes, the advanced users will know this, but sometimes when you're having trouble picking a surface, see I can't quite get to that inner lip, you can right-click and switch between pick normal and pick front. If I do pick front, it's going to grab that surface because it's directly in front of my cursor. There it is. Okay. So at this point, actually let me show you a little issue with my pipe supports here. Is these aren't perfectly aligned on the seam here. And I want those to join in right there so I don't get small slivers. And I'm going to move these. Turn on points. We're going to do modify, move by, and move by is your general all-purpose command to move entities within FEMAP. If you need to adjust something small, you don't have to back out and adjust it in your CAD package. You can move it right here in FEMAP. So we're going to do move by surface. And we just want to move this surface, and we just want to move it up. And so I'm going to pick a point on the surface and pick this point on the seam. But I only want to use the Y component of that vector. So I'm just going to delete these other components. So I'll only move it in the Y. There we go. So it's moved right on the seam there. And we can do the same with this one up here. It looks like it's set up, but like we mentioned earlier, some of these small features are quite hard to see. I'm going to take a pause here for a second and let our train pass. All right. All right, so same command. We're going to move this surface to the seam and only use that Y component. I'm just zeroing out the other components of the vector. Now I'm ready to add it all together. So we know because of these complicated intersections like these pipes intersecting this cone or these pipe supports here, these tabs intersecting, the stitch isn't going to work. So let's just go directly to non-manifold add. And we've got 1, 2, 3, 4 solids. And there we go. Now I've got some stuff inside. Again, I always like to have it overlap, like these pipes penetrating through, to ensure that the parts are going to connect and delete off the extra material, rather than leave a gap and later on in my project discovering that I have a gap and something's not connected. So this is a kind of technique that it requires you to delete surfaces afterwards, but you're guaranteed to have this connection. And to get inside of this tank here and delete some of these surfaces, it's going to be tricky peeking through this little window. So we're going to use the clipping plane, and this is under the little view style cube. You do the drop-down menu, and down here at the bottom is our clipping plane. So we'll select our plane that we want to clip on. I like to use the global plane technique, and we're going to clip in the YZ plane, and we'll just put it at 0. So the plane is located. Now we need to actually go back there and turn it on. There we go. So we have a nice little clipping plane, and we can see inside our fermentation tank. Again, I've got some more cleanup work. We're going to delete some surfaces, just these here. There we are, nice and clean. And I'm going to switch the side of my clipping plane. So I want to look at entities on the other side, and that's positive side. We uncheck that and get the negative side. We will delete surfaces. So the tops of my pipes here from the supports, got a little extra material from these pipe support tabs. Okay. We've got a nice solid here. One thing that my fermentation tank is missing here is this pipe coming out of the top. And there was never any solid geometry. You can see that there's a curve there for the profile, but we don't actually have a tube to work with. And I'm going to do a little bit of custom geometry within the FEMAP interface. And this is something that we've kind of been introducing more in our webinars and our trainings because we use it quite a bit, but it's not a commonly discussed technique. And so there are certain things where it's just easy to build something right here in FEMAP if it's quick and simple. We're going to need to use our work plane. If you right-click, work your way down, you see work plane. And so this will give us a plane to draw curves on. I'm going to use a global plane, and I want the horizontal, the ZX. And I'm going to put it right at the bottom of that curve there. Now I want to draw a circle. So I go to curve circle, and I'm going to say center. And this allows me to pick the center of the curve and the radius. And I want a 1.5 inch radius here. Okay, so we've got our profile, our cross section. We just need to actually create the surfaces. So geometry, surface, and you can see there's extrude, revolve, sweep. There's lots of commands here. We're going to use sweep. So select curves and cross section to sweep. That's our cross section. And then select curve to sweep along. And that's this one here. And we can just keep doing this command and work our way around until we get this pipe built. Cross section. And there we go. Last one here. Okay. So now that we have our pipe, we can add that in as well. Geometry, surface, non-manifold add. So we're going to grab all of this here, and that will incorporate our pipe into the rest of our structure. So this is all of kind of the base and raw geometry prep that we need to do. The rest of the geometry prep that we're going to do is basically just to help us subdivide our sheet solid and help promote high quality mesh. And I'm going to start with the curves on surfaces toolbar. So if you right click up in the blank space up here, this is where you turn on and off all of your toolbars. And what we want is curves on surfaces. So I'm going to turn it on. I'll drag it out here so you guys can see. And this is a lot of commands that are aimed at just with working with sheet solids. They never really split it up into multiple solids, but they do split your surfaces so you can help propagate higher quality mesh. A couple things I want to use here that some of these commands are available in the meshing toolbox, some of them aren't, so I'll introduce the ones that aren't available. One of them that I like is curve surface slice, and this will basically slice your sheet solid, but still keep it intact as one whole solid. I'll show you. We're going to slice this, and let's say I wanted to slice off the bottom of this cone for some reason. So we're going to use the horizontal plane, and I want to pick right somewhere in the middle, and there's no points or anything to pick to. Here's a nice little FEMAP secret. If you use Control-Z, you get another location selection. So here we can use our methods. Say I want to pick a midpoint of a curve. I'm going to pick the midpoint of this curve, When I click OK, it sends those coordinates to this dialog box where I can specify my cutting plane. There we go. So I've sliced through my solid there. You'll notice in the model tree it's still one solid. The surfaces here share this curve, but I have some nice subdivisions to work with for later on. Another one I like to use here is the curve or washer command. Washers are for circular holes in flat surfaces. For everything else, you can use offset curves. And we're going to do an offset curve, maybe about 3 inches. And we're going to do this nozzle up top here. And auto-select surfaces, if I pick these surfaces that go around this here, auto-select, it's going to imprint an offset curve on everything next to it. And I want to actually have control over that. I don't want to do it automatically, so I'm going to turn that off. Okay, so now I need to select my edges to offset, which is going to be these 4 curves around the outside of this. There's switching modes if you need to. Alright, so there they are. And now I want to select the faces to imprint, and I want to imprint on the top head. There we go. So I click OK, and you can see it just offsets this curve 3 inches out and connects it up. So we have a nice little washer around there. We can do the same with a lot of different components here. I'm not going to work through the entire model, but I'll give you a few examples. This opening here, figure if this was pressurized, the junction between the shell and this flange here might cause some high stresses. We want to make sure we have good quality mesh around this. So those are my curves. And this will be my face, the main shell. There we go. Very useful command. It doesn't work on everything, but a lot of times it'll give you information when it doesn't work. If we wanted to do one around this leg like a repad, we pick that. You can see down here in the message window, error sweeping along edge curves, offset not possible, try a smaller offset. So basically if I wanted to create a repad reinforcement here, 3 inches would just be too big and it wouldn't fit. We try something smaller like 1, grab those curves, and grab that surface. There we go. It puts a nice little annulus around there. At this point, I'm going to put a mesh size on my solid and mesh it. And any other commands that we're going to play with, we'll do within the meshing toolbox. And we can use those after it's been meshed because they will automatically update the mesh. These commands here do not update the mesh. So if your structure is already meshed and you start using curves on surfaces, you'll be modifying the underlying geometry, but your mesh will not be updating. So I'll just park this up here. We're going to do mesh, control, size on surface. We'll size all of these surfaces here. And we're just going to use the default size. You can see at this point that we've got these little dots along the curves, and that's what our mesh size is going to look like. Now we're going to mesh, geometry, surface. And I'm going to use the previous button. It's just going to pick all the same surfaces from my previous command. And you can preview them if you want to double check. Okay. Now we need to assign a property. I haven't created any properties yet, so we use the little shortcut key. We need a material. We don't have any of those, so again, I'll use the shortcut key. And this is purely a meshing exercise, so it doesn't really matter what material or what thickness we use. We just need something. Okay. So we have a mesh on our structure. And at this point, if we're going to work with the meshing toolbox to play around with the mesh sizing, the most important thing is that we improve the mesh quality. And you can actually contour the mesh quality with this Model Data Contour button. And this is very useful. You can show a lot of different things about the model. So we need to turn it on. And if you expand element quality, we're going to look at the Jacobian. Warping is also very important with curved structures like this. We'll start here, and we're going to allow labels. Okay. So here we have a post-processing style contour, but it's actually contouring the element quality. One thing we want to do is be able to find our peak. So let's make sure that we have these labels turned on in View Options. We want to make sure that under our contour style, we'll label our max. So there we go. We can actually find our worst elements quite easily and use these tools to help eliminate these elements. I'm going to turn this off for now. We can check back on it in a bit once we've done some work on the model. There's a couple of things that I want to discuss with the meshing toolbox, and some of them are commands that are similar to the curves on Surface's toolbar, and those are under geometry editing. So you can see we've got the washer, the pad, and these point-to-point, point-to-edge. These are very similar commands to what you've got here. But these ones will actually automatically update the mesh. So let's start with a pad. And we've got a little circular hole here for a pad. And this is quite nice. I'm going to turn on my meshing toolbox selector. You see as I get close, it hovers over those circular curves. I click that, and it's created a pad for me. And if I blank the mesh and turn on our surfaces here, you can see that it divides it, puts a box around it and divides it into 4 quadrants. It also creates mapped meshing, which we're going to talk more about a bit. But you see the quality of this mesh. We turn this on. Oops. Turn on our Jacobian. You can see the quality is very good quality. We're all around 0.5 or below for this section here. So let's try something different for the bottom. Another command we've got here is washer. We'll try this. Put a washer on there. And you can see that the way this is confined here, the washer has actually created some tiny little slivery elements. So maybe washer isn't the best. Maybe the pad was the better command to use. So at this point, we could just do Control-Z and undo. But say we'd put this washer in, done all sorts of other commands, and undo isn't really an option. The meshing toolbox gives us feature removal. So we could remove some curves. Let's turn this on. You see we pick the outside curves of that washer, these little divisions here, and we're able to remove that feature even though undo was not available. Okay, let me shut the window real quick. All right, is that any better? A little louder. One second, guys. We have some technical difficulties. Yeah, they got sound.
So it sounds like Adrian, at least in my headphones, he got quite a bit of static. Can a few of you guys mention in the chat if you had that static as well? We just want to make sure that we get good sound quality for everybody.
Testing, testing. 1, 2. Everyone has static. Okay.
Yeah, everybody has static.
Let me see here.
All right, bear with us for a second. We'll try to get that worked out.
Okay, testing.
That sounds much better.
Really? Okay.
Yes.
All right, I'm back. You guys give me a little confirmation in the chat. See if this is any better. Better. All right. This is the Windows technique. Turn it off and turn it on again. Okay, so feature removal. If you need to get rid of something stubborn, you can always use this command here. All right, moving on. The most common thing that you use the meshing toolbox for is mesh sizing. And this is great. It's really easy. On the fly, you can increase or decrease mesh size along a curve, and it'll update it automatically. So right now I've got the mesh sizing box. It's set to increase, and it's going to increase by one element at a time. And I've got my selector on. So let's try it here on this. And you can see I can just kind of play along and use this element quality contour as my guide, whether I'm helping create a higher quality mesh or if I'm just clicking to waste time. Something that this brings up, if we turn off our surfaces, is if I can update the mesh size on this pipe, you'll see that if the opposite edges of the pipe don't have matching mesh size, the mesh goes a little wacky. So right now we've got maybe 8 curves on each side, and if I add one here, my pipe kind of collapses. So we want to ensure that we have similar mesh sizing on opposite edges. And really what that is mapped meshing. Just like our little pad here, we've got equal mesh size on this curve and this curve, 2 and 2, and this curve and these combined outer curves, which it looks like we've got 6 and 6. So that propagates this mesh from the inside of the curve to the out, and the other direction it kind of sweeps it around. So let's set up mapped meshing for our pipe. This command can be found in the meshing toolbox. You go down to mesh surface, and there's lots of options here. We're going to do mapped mesh. Our element type is a quad 4, and that's our 4 noded plate elements here. And our mesh sizing will start with size all connect. So if I click this surface here and the lower half here, you can see that it's kind of enforced this mapped meshing. It's also resized all of the curves to kind of match with our default sizing here. And we can just work our way down this pipe and set up our mapped meshing. And we'll get to the point where the whole thing will be mapped, and we can kind of pick our mesh sizing at one end, and it'll propagate through the rest of the pipe. So let's try that. We'll go to mesh sizing. We're going to increase by 1. We're going to increase this one here. And if you look at, as I do this, it propagates up to the next surface, all the way through. Since all of these surfaces are mapped and they're all adjacent, that mesh size is going to propagate its way through and update the entire pipe. This is also useful for these corners. You can see I can add density to one side, and the other side automatically updates until we have a nice little curve there. Some other mapped meshing options here. This bottom section of the cone is just a 4-cornered surface, so let's try mapped mesh. I talked a little bit about the sizing options. Default is size all, and if we click on this, you can see that it automatically updates the sizing on all the different edges. Say you've got a structure and you've done a lot of work on the sizing and the mesh sizing, you've got it set where you want, and you don't want to use this command because it might override a lot of the sizing you've already done. I'm going to do an undo, and we can turn this to off. So let's set these as mapped mesh. And you can see nothing's actually happened to the mesh. So I've told it that I want to use a mapped mesh, but I've asked it to not automatically resize for me. So now let's go down to mesh sizing, and we can pick the size. Say we just want to add one curve here or add one here. It waits for me to instigate the mesh sizing rather than automatically resizing for me. So that's about it on the meshing toolbox. You can see there's lots of little areas here in this model where we can chase down, we can work on the mesh sizing, we can set up to mapped meshing. But this little it's pretty complicated, and it could take quite a while to get everything going correctly. This model is going to be available for you guys, so if you want something good to work on and practice your meshing toolbox techniques, this is going to be a good thing to work with. And you can work your way through, find all the problem areas, and use it as a good study. Before we wrap up today, I also want to introduce a new API that we've written. And some of our friends work in the aerospace business, and the engineering reports are very intense. They require lots and lots of documentation. And something we were looking for was a way to label selected elements and nodes. So let me turn off my contour here. And say we wanted to just take a look at some of the elements and nodes in this corner. Now FEMAP has the capability to label any sort of entities with their ID numbers. If we go to visibility, you can see here we could go over to labels and say we want to label our nodes. And we turn this on, and we need to make sure our nodes are turned on as well, and we get the ID numbers for the nodes. The problem is it labels all nodes, so if you're zoomed out, it's really a mess and you can't see anything. We say we just want to work with a little section here. Same goes for the elements. If you turn that on, you get everything. So we wanted to do just a small selection here, so we wrote an API. And if you haven't used an API before, you can access these under Tools, Programming, API Programming. And this opens up the API Programming pane. And you don't have to do any programming yourself. You just have to open the program. This program is called Label Selected Elements and Nodes, and this will be included in the download file. So we open this, and you click Play. Now the first thing that pops up when you run this program is this little information. Do you want to delete all text entities? This program is going to create text entities, and if you pick a lot of elements and nodes, it's going to create a lot of text entities. So it gives you the option to quickly wipe all these out. I don't have any existing ones, so I can click No. All right, select elements to label with ID. We can just grab a good chunk of elements here around this corner and select some nodes. We'll grab some nodes, and we'll grab some nodes over here as well. Okay. Program completed, you can see in the message window. If you don't see any labels right away, go back to visibility and make sure that you have text entities turned on. There we go. So what this program does is it labels the nodes without parentheses. It places the label directly over the node. And it labels elements with parentheses, and it places it at the centroid of the element. You can see that it'll generate a lot of these boxes, and it can get messy really quick. If you want to clear up the screen, you can always just run the program again, delete all text entities, and maybe this time we'll take a little more conservative pick here. We'll grab this element and just these 4 corner nodes. Okay, so you can see we've got element ID number, node ID numbers, and a handy API to create and delete these. So that's pretty much it. If you guys have some questions, we'll check in on the box here, and we got a little time left to address those. But one last thing I wanted to bring up was our training session in April. Let me bring up our flyer. We do FEMAP and NX Nastran training, and I'll bring this flyer up for you guys. We'll include it in the download. Every 6 months or so, we do a class here in Portland. It's a 2, 4, or 5-day class. The first 2 days cover the foundations of FEMAP and NX Nastran, kind of an intro to FEA with some advanced techniques. The second 2 days are advanced analysis, and the final day is API programming. So we'll spend the entire day dedicated to writing programs like this, learning how to read them, how to debug them. So let me just bring up that flyer for you guys, and we can wrap up for the day. Do we have any lingering questions here?
Yeah, we do have one question. Well, actually two, but I answered the one about when the presentation will be available. And then Andy is asking if we can discuss the benefits of mid-surface modeling versus solid modeling.
Oh yeah, that'll be a nice little quick and easy one. Yeah, I'm not sure what you said on the download. Usually it takes us, best case scenario is a couple days to get everything organized, get the video processed and uploaded, maybe a week or so before everything is ready to go.
Yeah, I think I said early next week is probably a good, early to mid next week.
Yeah. Okay, so let's do, we'll do the quick, easy comparison here. So this model, let's say we're done with it for now. We've got a node count of about 6,000. You see in the bottom left-hand corner here, FEMAP gives you a node count. So about 6,000. Now we're going to open up, we'll save this one, save as work in progress. And let's open up the original model here. Okay, so we would have to add together these solids, but that's not going to drastically change our mesh count or our node count. Let's just go straight to mesh control, size on solid. So we want to mesh all of these solids here. And our mesh sizing, I think it was even smaller. It was something like 4.8 maybe. So we'll use the same mesh sizing that we did for our plate meshes. Okay. And then let's mesh. We're going to use a solid mesh on these previous solids here. We need to pick a material. Okay. All right, so we are sitting at 44,000 nodes. That's almost a 10x increase for a similar mesh size. If you think about that, we haven't done any work to increase the mesh quality or the mesh density around our problem areas. And if we look at the thickness here, we only have one element through the thickness of this plate. And we're going to have a hard time capturing the bending effects, kind of the through thickness stresses, just because we're not going to have the same sort of resolution as we would with plates. So yes, this is a quicker process to get your model meshed. You're going to end up with a much larger, much slower model. And for thin-walled structures like this, you're actually going to end up with less accurate results unless you can go in and kind of force your element to have, or force your model to have a couple of elements through the thickness. We could do the meshing toolbox with this. Let's go ahead and increase the mesh size here. But you see, we don't have any curves to set the thickness or to set the through thickness element count. So even with the solid geometry, you're going to have to put in some geometry prep work. Okay, that about wraps it up. We're getting close to an hour here, so I'll cut you guys loose. But follow up by email if you guys have more questions, and either Nate or myself will get to you. And thanks for coming today.